Passive heating consists of many different strategies, all which end up with altering design elements to achieve a better distribution of heat internally, an absorber body with a high thermal mass, calculating the right amount of opening, and ways to control excess heat and solar radiation. This project focuses on designing and testing the efficiency of 4 main strategies, 3 of which are designed. Improving upon the insulation compared to the codes and regulations of Denver, using trombe walls, direct gain, and sunrooms. This is part 1 of the project. The aim was to design a building using passive cooling strategies. This is the entrance view. This is the back view or the courtyard view. As we see, the courtyard, that's the lobby, and this is the spa. This is the first floor plan. Again, showing space adjacencies. That's the entrance, the lobby space, the reception or the cafe, and then up the stairs to the meditation room, or we go through either of these doors to the spa. And this is the meditation room overlooking the roof of the spa area. This is a transverse section cutting through the spa, meditation room, and the courtyard. And a longitudinal section cutting through the staircase, the changing rooms, and the spa. To test passive cooling strategies and the efficiency, we had to test the building in Dubai. It was located away from the sea in a residential area in Al Khawanij. This was the plot next to a shopping mall. And then in order to test the passive heating strategies, we had to take the building to Denver. And this is our new plot. This is our site in Denver. And as we see, there is a road in front of the site and then a ramp going up to an upper road back there. These are adjacent buildings near it. Here we see there is a slope on the hill. However, our site is flat. And this is the view of our site from up the ramp, so basically looking down. And this is where the building is situated on the plot. In the following 3 diagrams, we can see that Denver has quite an extreme climate. In summers, the temperature goes as high as 35 degrees Celsius, and in the winter it drops to as low as minus 24 degrees Celsius. Barely only 2 months fall within the comfort zone range, and all the rest are much lower. So the month of July and August fall in the comfort level range. Even though Denver has quite a topography, the wind velocity is not as much as we think it is, only 4 meters per second on average throughout the year. Now, this information can be useful if there would be a question of whether or not to depend solely on natural ventilation for cooling. The sky coverage of Denver is to be noted because on an average level, the coverage is 48%. This will help to understand the effect of solar radiation on the surfaces of the building. A trombe wall is simply a construction of 2 materials that is placed on the south facade. From the outside, a trombe wall looks like an inoperable window that is closed by a wall behind it, or a very narrow greenhouse. The glazing has to be single glaze in order to absorb the most amount of solar radiation that hits on it. On average, the gap between the glazing and the back wall is about 5 to 30 centimeters. The more it goes, the least effective it can get. Openings are made at the top and the bottom of the wall to allow for convection. The air between the wall and the single glazing gets heated up quite fast, and through the help of vents, as shown in this computer simulation, or through differences in air pressure, the hot air is constantly drawn in the interior space. For this project, trombe walls are used on the south facade on 3 different wall surfaces. Direct gains work best for cold climate. That's why for the Denver project it was one of the strategies used, which was quite efficient as well. It is a process in which the sun's ray passes through a glazing and gets absorbed by the floor of the interior space, creating heat in the space through the release of that radiation from the floor. Now, it is very crucial to have a proper thermal mass for the flooring, which absorbs the radiation during the day and releases it during night. In this project, the areas above the trombe wall are used as direct gains. A sunroom or a sun space is an isolated gain system. It can either be an attached greenhouse-like structure to the south facade, or it could be a part of a space without any interruptions in the plan. For this project, the space that is extruded outwards towards the south is partially used for the purpose as a sunroom, even though the system is used as a small portion compared to the size of the room, but yet it was quite efficient. Here we see the sectional plan of the project. This is the entrance place where one arrives, which can be called a reception as well, or a lobby. And then there is a corridor here which can take the stairs, go up to the meditation room, or take either of these doors to the changing room and the washrooms, and then come into the spa area. This is the second floor, where it's an open plan for meditation. Taking perspective sections through the building can help understanding the adjacencies of the spaces. This is a transfer section into the washrooms or the changing rooms, and the lobby and the space above that, which is the meditation room. And then here is the spa and the continuation of the meditation room. Here are a couple more sectional perspectives. This is a longitudinal section. The lobby or reception area. This is the main entrance where you come in, the washroom, changing rooms, the spa, and the meditation room. following two graphs best illustrate the drop in energy consumptions and load when each strategy was tested individually and when all are tested together, starting from the most efficient to the least efficient in terms of the reduction in the total energy. When we improved the insulation, we got a 48% of reduction, which are the yellow bars. With direct gain, we managed to reduce 34%, which is the purple bars. With trombe wall, 17% was deducted, which are the red ones. For the sunroom, only 5.5% of reduction was seen through the simulations, which is the blue bars. And eventually, the cyan-colored bars show that when all of the strategies were put together and tested together, there was a drop from 49 megawatts hour to 12.8 megawatts per hour, which means there is a 74% reduction. The results for the amount of room heating loads is quite similar to the total energy. A temperate climate lies between the two areas that the design was proposed. Therefore, the passive strategies will be in common with the rest. Direct gains and sunrooms are highly recommended for such climates because they too have cold winters. However, the shading devices has to be carefully calculated so it can bring in radiation during winter and keep it away in summers. Night insulation can also be a good strategy to be used for temperate climates.